Particle moving in a straight line, its displacement is this. It's a nice complicated thing here. Between 0 and 6.8. So I'm only interested in these times as shown on the following graph. Find the initial displacement at point P. Well, first thing I'll do is draw the graph to make sure it looks the same, making sure I'm in radians and making sure I go from 0 to 6.8. Page number 2. And let's draw the graph they've given us for S of t. So that's 3. I'll put a multiplication for the brackets just to make sure. X plus 2 to the power cosine t. Make sure I'm in so cosine x. Make sure I'm in radians because it's got cosine limits. Yeah, that's okay. I want to go between 0, so 0 there, and maybe go a bit higher here, so I'll go to 15 here, and up to 6.8. I can't quite see all of it, so let's make this a bit taller here. Let's go up to 20. No, let's go to 30. Oh, there we go. Now I can see the graph, and that looks like the one it does in the question. And the initial displacement from the point P, well, this is F1. I could just do add a new calculator page, 1. I could just do F1 of 6, which gives me Control Enter, gives me that value there. Sorry, F1 of 0 I should be doing, shouldn't I? F1 of 0 gives me 6, so it's 6 meters away at the start. And I can also do that on the graphs page, go back a page and do menu, geometry, points and lines, point on, click on a point, and then escape from adding in points and put 0 there for my x value. 6, it is 6. So when we've done that, we've got the initial displacement is part A, 6 meters. And actually I can mark it on here. Actually I should draw a new graph to show what that looks like. So that is a graph like this. Find the velocity when t equals 2. I can either do a velocity graph, or I could just do, so I could do that. So I could do, let's try a velocity graph. Tab, and I want the differential of the, so differential of the IDX of the F1, which is my displacement graph of X. There's my velocity graph. And when t equals 2, I'll just do a point on that. Menu, geometry, points and lines, point on. Escape from adding a point on and change that to 2. And I get the value there. So that's the velocity when t equals 2. I could also do menu, analyze, do dy by dx, number 5. Click on this graph because the displacement and position is at 2. And it gives me exactly the same value. Because we're on a separate sheet. And here, this is y equals s of t. And this is 0, 6. Let's move my part B to below that, so that's in part A. Part B, find the particle's velocity when t equals 2. So then here, I can just do, put this as 2. Find the gradient at that point. It's actually m equals negative 2.299 ... So B is V of 2 equals negative 2.299 ... which is approximately equal to negative 2.30 meters per second. Part C, determine the intervals of time when the particle is moving away from the point P. So I can either find the maximum there and the maximum here and the minimum here. But actually what we did was, what we should do is plot a graph of velocity. Now determine the intervals of time in the period when the particle is moving away from P. So it's moving away from P when the velocity is positive. Negative velocity is moving back towards it, and that's when it's moving away from it again. So let's put a new graph at 0, and let's find the intersection points menu, geometry, points and lines, number 4, intersection points, and have this graph with this graph, and then it gives me the times when the things should be moving towards or moving away, just so I can see it a bit better. So actually it's moving away before 0.433 and then from 3.2558 to 6.3397. And then it's moving back towards P again. So the graph velocity looks like this. And this is 6.8 here. This is y equals v of t, which is s dashed of t. And this is here 3.255 dot 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 comma 0. So C is determine the initial time the particles move away from point P. And this one here is 0.4330 dot 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 0. And this one here is 6.3397. So now we need, this is T, so T has to be less than 0.433, or T has to be greater than 3.26 and less than 6.34. So those are my values for T shown clearly as intervals and shown what T is allowed to be. The acceleration of the particle is 0 at these points. Find the values of B and value of C. Let's draw a graph of acceleration. I can escape from adding in points. Find the value of B and the value of C, which is when the acceleration is 0. So let's do an acceleration graph. This is getting a bit messy now, so I might do it on a new page because I've got too many things on this page. So I'll add a new page and do another graphs page. And now let's do the second differential of displacement. I can do with this, or I could do the displacement of the velocity that I've just done. I'll do second displacement of this, and that's of F2 was my velocity graph. That's my y equals a of t acceleration, which is s double dash of t. I've got the wrong. It's taken a long time to draw this bit because I've set this wrong. 1.2314 to be and 0.6896, and we have this. So let's go t to equals 10. 1.23. Or t equals, and we only want to go up to 6.8. 5.69. So b equals 1.23. So and C equals 5.69. 20 here just to see. So those are the 2 points you wanted. But actually only when it's 0, so it should be okay. C and B should be smaller than C. So find the value when the acceleration is 0. Find the total distance travelled by the particle for this. And what I actually did was, I could do is integrate that. Because I've got 2. So I can integrate it from, what was my, it was F1, it wasn't F2. 3.18. This one is F1, I've done the second differential on graph. So from there, we get that bit. So this one should be, and this bit's not F2, but F1. 5.68. That's better. 6. So now I've got point B and point C here. That bit. Let's add in. So we're actually doing the integral from, and I'd add in the last 1.2314. That may need to do a new one. Yes, it has to put it on there. So if I do that graph there now, find the intersection points of menu, geometry, of t, points and lines, intersection and points. That negative between 0 and this integral from 2 points, 3.255, 0, which is here and here, to 5.6896. And the total distance travelled between B and C. So let's store this as a variable. Which equals, so escape to stop adding in intersection points. Store that as acceleration 0 first point. and store this one as acceleration 0 second point. But B and C, actually, so you do a B and C as well, but now I've got the 2 points there. I want the distance traveled. So go back to this graph. I can either distance traveled between B and C. I want to go from somewhere here to somewhere here, but I need this middle point, which is when the velocity is 0. So I'll store that point as velocity 0. Because then I want the area under between this point and this point and the area underneath it for the next point. Or I could do that value to that value and this value to this value on the original graph, which would also work. So let's try doing both on a calculator page. So I go right a page to get to the other graph, then right again to my calculator page. Let's try doing the integral. So I could do the integral, which is here. The integral from point B, which is acceleration 0 first point, up to when the velocity is 0, which is velocity of 0. And I want to do F2, because that's my velocity graph, dx. And then I could copy that to do the same thing, but now I'm going from velocity 0 to second acceleration being 0. So that's acceleration 0 for the second time. And that goes to this distance. This one comes out as negative because it's moving negatively. This one comes out as positively. So I'll do this one, subtract this one. And you'll see I'll get exactly the same things if I do F1 of those values. So I do F1 of the acceleration being 0 at first, F1 of the velocity being 0, and then F1 of the second acceleration stop there. And if I do this one, subtract this one. Oh, look, there's my 15.9696, which is the same as that one. So that's between acceleration 2 and velocity 0, 0, 2. And I can do the same one with, I can do this one, subtract this one, which in other words is, this is how far away it was at the third point, subtract how far away it was at the first point, then how far away it was at the second point, subtract how far away it was. That's, sorry, the first point there. How far away it was at the beginning compared to how far away it was at the second point. So first point to the second point. And then I just have to add those two up. And I get the same thing. I get 19.00, which would be the same as adding these two ones up here. Adding these two up here, I've got the same thing, 19.552. The value we found in our nice little calculator, 19.5525, which is approximately equal to 19.6 meters. And I've explained where that's come from. We can see the acceleration graphs, so the method marks are all there to work that one out.